Hello again. So, now we are looking at a triangle different from the 45, 45, 91. As we can see, there's two 60-degree angles. Now, due to the fact that all the angles of a triangle have to add up to 180 degrees, we can conclude that this remaining angle here is also 60 degrees. Since if they all add up to 180, and the previous two are 60, 60 and 60 is 120, 180 minus 120 is 60. And if we know all the angles in a triangle are 60 degrees, that means we have an equilateral triangle where all the sides have the same length to them. Now I'm just going to get rid of that for now, but we can come up with some interesting properties with this equilateral triangle. Now, we were talking about right triangles previously, so what does this have to do with a right triangle? Well, if you drop the altitude from, let's say, point A to BC, you'll get, the triangle's height, its altitude, and it forms a 90-degree angle. And we've made some new point here. I'll call it like M for the midpoint, I guess. Now, okay, so what can we establish from this? Now we have like two 90-degree triangles technically, since, we split this equilateral triangle in half in a way. And that's precisely what's so important about this is like, since we're splitting the side BC in half, if I say that, for instance, the side MC has a length of x, then BM would also have a length of x. So the entire side BC has a length of 2x. And since the triangle ABC is equilateral, that means BC is the same length as AB and AC, so they're both 2x as well. Okay. So I'm just going to get rid of this for now. That's interesting. What's also interesting is like if I know we have a 90-degree angle here and C is 60 degrees, then I can determine what this angle over here is. If I do 180 minus 90 minus 60, well, that's 180 minus 90 is 90, minus 60 is 30 degrees. So this missing angle here is 30 degrees. Okay? So, looking at what we have so far, we have, if we're looking at the right triangle, we have two of them. And I guess I'll highlight the one I'm going to be focusing on in blue. So this right triangle here, AMC, we know what two of the side lengths are. And I'll rewrite them in blue to stay a little bit consistent. So if this had a length of x, then this has a length of 2x. Now I have this missing side here, that height. What is that side equal to? Well, I can apply the Pythagorean Theorem and determine what that missing side is using the other two pieces of information we know. So, let's give this a proper variable name like y. I'll call that y. So, using the Pythagorean Theorem, I have that y squared plus x squared is equal to 2x squared. Since again, 2x is the side opposite to my right angle, so it must be the hypotenuse. And let's see if we can simplify this out. So 2x squared, 2x times 2x, well, 2 times 2 is 4, and x times x is x squared. And then we still have our y squared plus x squared. Now, I can subtract x squared on both sides of the equation. I have y squared is equal to 4x squared minus a 1x squared, right? So 4 minus 1 is 3. So we have 3x squared left over. If I'm going to solve for y, again, we're going to take the square root on both sides. I'm left with y equals. Now, I could separate it out like I did last time, but I think we kind of get the gist. The square root of x squared is just x. And then the square root of 3 isn't going to simplify at all. So we're going to keep it the way it is. So we actually determine that we can find out the value of y in terms of x. So at y right here can be written as x times the square root of 3. Which means if we have a triangle, a right triangle that has an angle of 60 degrees and 30 degrees, we now know how we can express all the side lengths in terms of some consistent value x. And we make basically a ratio of the sides. So this is another special type of right triangle that's super important, especially in trigonometry. The 30, 60, 90 triangle, where the short leg is the one opposite to the 30-degree angle, that has a value of x. The longer leg has a value of x times the square root of 3. That's the side opposite to the 60-degree angle. So here's the smaller side, or the smaller leg, larger leg. And then, of course, the hypotenuse we found was 2 times the value of x. So if I have a 30, 60, 90 triangle, as long as I know one of the side lengths, I can find the rest fairly easily using this ratio laid out. So in the next video, we will explore some problems involving this type of triangle.